Picture Yellowstone National Park. Geysers shooting skyward, hot springs glowing in unearthly blues and greens, bison grazing under a vast Wyoming sky. It's a scene of raw, natural beauty, one that feels timeless, almost eternal. But here's the thing. What you're seeing is just the surface, a fleeting snapshot of a landscape that's anything but still. Beneath those bubbling mud pots and steaming vents lies a geological titan, a hidden force that's been shaping this land for millions of years. Yellowstone's caldera, a massive volcanic system, is the park's beating heart, and it's far more dynamic and potentially dangerous than most realize. So, what's really going on down there, and what does it mean for the future of this American icon? Let's start with the basics, but don't worry, this isn't a geology lecture. Imagine the caldera as a giant, restless beast sleeping under the park. It's not just one volcano, but a sprawling volcanic system, roughly 45 by 30 miles wide, formed by catastrophic eruptions over millions of years. This is no ordinary volcano. It's a supervolcano, one of the largest on Earth, capable of eruptions so massive they could alter the planet's climate. The last big one, about 640,000 years ago, left behind the Yellowstone Caldera we know today, a sunken bowl of earth where the ground collapsed after spewing out unimaginable volumes of ash and lava. That is the kind of power we were talking about, enough to make you rethink that peaceful hike through the park. But here's where it gets wild. The caldera isn't just a relic of the past. It's alive, pulsing with energy. Deep beneath the surface, a massive chamber of molten rock, magma, churns and shifts. This isn't some sci-fi movie plot. It's real, and scientists are piecing together what it all means. Seismic studies and satellite data show that the ground in Yellowstone is constantly moving, rising and falling like the chest of a sleeping giant. Between 2004 and 2009, parts of the caldera rose nearly a foot per year, driven by magma or superheated fluids pushing upward. More recently, the ground has settled, but don't let that fool you into thinking it's gone quiet. Yellowstone is always active, always changing. So, what's fueling this restless beast? The answer lies in a plume of hot rock rising from deep within the Earth's mantle, a feature geologists call a hotspot. Think of it like a blowtorch aimed at the underside of the North American continent, melting rock into magma as it goes. This hotspot has been stationary for millions of years, but as the continent drifts westward, the hotspot has carved a trail of volcanic destruction across the American West, from Oregon to Wyoming. Yellowstone is just its latest stop. The magma chamber beneath the park is massive. Estimates suggest it holds enough molten rock to fill the Grand Canyon several times over. And it's not just sitting there, it's dynamic, with new magma flowing in and gases bubbling out, keeping the whole system in a state of constant flux. Now let's talk about what's really hiding down there. The magma chamber isn't a single tidy pool of lava like you might imagine. It's more like a sponge, a mix of solid rock, molten magma, and pockets of gas, stretching miles beneath the surface. Scientists using seismic waves have mapped two main chambers, a shallow one, about 3 to 10 miles deep, and a deeper one, extending down to 30 miles or more. These chambers are interconnected, feeding the geysers, hot springs, and steaming vents that make Yellowstone so iconic. But they also hint at something bigger. The deeper chamber is enormous, potentially holding enough magma to fuel another catastrophic eruption. The question isn't if Yellowstone will erupt again, but when, and what that eruption might look like. Here's where things get a bit unnerving. A supervolcanic eruption from Yellowstone would be unlike anything modern humanity has ever seen. The last major eruption, 640,000 years ago, ejected about 240 cubic miles of material, enough to bury the entire United States under a layer of ash several inches thick. It cooled the planet for years, possibly triggering climate shifts. If something like that happened today, the impacts would be staggering. Ash clouds choking the skies, crops failing, air travel grounded, and entire regions blanketed in toxic debris. But before you start picturing an apocalyptic blockbuster, let's put things in perspective. Still, the caldera's activity isn't just about eruptions. It is also driving the park's hydrothermal features, those geysers and hot springs that draw millions of visitors each year. These are powered by the heat of the magma chamber, which boils groundwater into steam, creating the explosive displays of Old Faithful and others. But even these features are unpredictable. Geysers can change their eruption patterns or stop entirely as underground plumbing shifts. In 1985, for instance, the Porkchop Geyser exploded, hurling rocks into the air after its vent became clogged. It is a reminder that Yellowstone's beauty is tied to its volatility. Every steaming pool is a window into the caldera's restless heart. What does all this mean for us? For one, it's a humbling reminder of nature's power. Yellowstone's caldera is a living system, one that's been shaping the landscape for millions of years and will continue to do so long after we're gone. Scientists are watching it closely, using tools like GPS, seismometers, and satellite imagery to track its every move. They've found that the caldera breathes, swelling and subsiding as magma and fluids shift below. Earthquakes, often small but sometimes significant, rattle the park regularly. Over 1,000 quakes are recorded each year, most too faint to feel. These are signs of a system in motion, not necessarily a prelude to disaster, but a clue that Yellowstone is far from dormant. The future of Yellowstone depends on how this system evolves. Will the hotspot keep feeding magma into the chamber, building pressure for another eruption? Or will it simmer quietly for millennia, content to power the park's geysers and springs? No one knows for sure, but the stakes are high. An eruption, even a small one, could disrupt the park's ecosystem, close roads, and affect nearby communities. Ashfall could impact agriculture and infrastructure across the western United States. And while a full-scale supervolcanic eruption is unlikely, it's not impossible. Scientists estimate that Yellowstone's caldera has produced 3 major eruptions in the last 2.1 million years, roughly one every 700,000 years. We're not due for one, but the clock is always ticking. Beyond the science, there's something almost poetic about Yellowstone's hidden depths. It's a place where beauty and danger coexist, where the Earth's raw power bubbles up in vibrant colors and explosive displays. It reminds us that the planet we call home is alive, constantly reshaping itself in ways we're only beginning to understand. The caldera isn't just a geological feature, it's a story of fire and time, written in the rocks beneath our feet. Visiting Yellowstone, you're not just walking on a park. You're walking on a supervolcano, one that's been shaping the world for eons. So next time you marveling at Old Faithful or soaking in the sight of a steaming hot spring, take a moment to think about what's below. That rumble you might hear isn't just your imagination. It is the sound of Yellowstone's heart, beating with the energy of a planet that's never truly still. The caldera is a reminder that nature's greatest secrets are often hidden in plain sight, waiting for us to look a little deeper. And as we keep studying, watching, and learning, we were not just uncovering the mysteries of Yellowstone, we were getting a glimpse into the forces that have shaped our world and will continue to shape its future.